Hi friends, welcome to Adda 24/7. We are in a Sankalpa series for important theory and objective questions on ABM, and we are in Module A, chapter number 2. Last lecture I had taken some part of Module A. Today I will be covering the remaining things. We will be mainly focusing on objective questions and one numerical, very important. Okay, so let's start. Okay, so firstly, what is the sampling distribution? What is a sampling? What do you mean by this sampling distribution? Actual word. Sampling. Sample means what? Suppose if there is a huge population, this is a full population of let's say 1 lakh in a city. So I have to survey these guys. Means I have to survey, let's say, salary. What is their salary? Okay, how will I survey? Should I contact all the 1 lakh persons in the city? But how much will it cost me? Contacting full 1 lakh persons. How many people will I require for surveying? So there are 2-3 points which are always to be considered. One is administrative cost, right? Cost. How many persons are required? What is the time required? What is the charge of each surveyor? Isn't it? First is cost, second is time. Huge time will be required, right? So that's why what do we do? Whenever we have such problem, what do we take samples from every part of the city. Let's say 10 samples from here, 10 from here, 10 from here, like that. Okay. So these 10 samples, whenever we distribute them, and we check the sampling distribution of these samples. We check how the salaries are distributed. Now 10 is, I gave you the example. We can call it 100 over here, 100 from here, 100 from here, and 100 from here. So these samples or the salaries of these persons will be distributed on a curve. This is the way they will be distributed. Okay, and this distribution is known as a sampling distribution. We always distribute the samples over here, and this is a population mean, means complete salary mean of 1 lakh persons, which I have got it from the secondary data. Always remember this population mean, I generally get it from the secondary data. This is known as population mean. What is population mean? So here, if I want the average salary of 1 lakh persons, I might have read it somewhere in the books, in the magazines, in the government survey, in the government report, that average salary of this city is, let's say, 30,000. If I have read it somewhere. But I want to check whether this 30,000 figure is correct or not. I've got it from some secondary figures. So this is known as the population mean, mu. This is shown over here, mu. Okay, this is mu. And the samples which I take, the samples will be distributed over here. All the separate samples will be distributed separately. There would be here. Suppose if I am having 3 samples over here, 100, 100, 100. Then there will be 3 sampling distributions similar to this. And then the curves will be plotted. So this curve plotted is known as a normal distribution curve. Okay, bell curve we call it. So what is the sampling distribution? A type of probability distribution created by drawing many random samples of given size for the same population. So type of probability distribution created by drawing many random samples. So after all, it's a probability distribution. It's a type of probability distribution which is created by drawing many random samples. Random means nothing is told over here. Means no judgment over here. I'll contact any 10 persons in any 100% in this area of that city. Otherwise, if I do it from on my own, that I'll contact only my known persons. So that is not random sampling. That is my judgmental, convenient sampling, you can call it, isn't it? So is A the answer? Or a type of probability distribution created by drawing many random samples from a given size from the different populations. Different means one from this, then this second sample will be taken from some other population, other city. So is this the case? Do we take it from different populations? Is it either A or B, both of them, or is it neither A or B? So what is the answer, everyone? It is here only the crux point is same or different. Okay. So what is the answer over here? Is it same population? Means the type of probability distribution created by, here this is the probability distribution created by drawing random samples. These are the random samples of the given size from the same population. So from the same population, I will take 3 samples. So that is the real answer. From the same, because here I have to survey this population only. So why should I go for other city? I'll be going for the same city. So that's why taking some samples, a fixed number of samples. Here, some is not varying as per my own wish. No, fixed number of samples. Okay. So that is sampling distribution. Everyone subscribe to Officers Adda 24/7 YouTube channel. In this channel, you will be getting the latest updates on JIB and CAIIB number 1. Here, 2 things are always needed. One is updates, latest updates. Means whatever IIBF says, it immediately comes to this channel. And second is free YT series, YouTube series. Right now, what are you watching? You are watching the same YouTube series. So you get the free YouTube series on these channels. Subscribe to it, click on the bell icon immediately. Okay. What is the sample mean? The sample mean is the average of set of data. Here, average of set of data. Now, set of data means what? Set of data means, suppose if this is a population and this is a sample of 100, let's say. Okay. So the mean of these 100, remember, not the entire population. Mean of these 100 is known as sample mean. Okay. So this is also known as, the other word for this is, anyone knows what is this statistic? Anyone knows what is statistic? Does it relate to this? So this is statistic. Statistic means anything done to the sample is known as statistic. Okay. Mean, mode, median of sample is known as statistic. And this is known as population mean. If I take the population, entire mean for entire population, that is called as population mean. Okay. So this is known as parameter. Okay. Got it? Parameter. So understand this. Always remember this. Sample, anything done is known as statistic. Population, anything done is known as parameter. So sample mean is average of set of data. The sample mean can be used to calculate central tendency. Central tendency means, here, central tendency, the word means mean, mode, wherever I get a single number, median, mean, mode, median. Okay. Standard deviation and a variance of data set. So wherever this sample mean is used to calculate all these 3, central tendency, standard deviation and variance. Or is it B, sample mean is an average of a set of population. So is it this for the population or is it for the data? So it is for the data. The answer is A, right? So what is the sample mean? It is a sample mean is the average of set of data and it can be used for finding all this. Okay, C and D are out. Okay. Now everyone download Adda 24/7 app on your mobile. In this app, you will be getting the premium study material plus live classes, ebooks, tests, and mind it, we are solving a numerical now. Very important numerical. Okay. So you'll get everything. So download this app right now. Now look at this numerical. This is the toughest numerical, one of them. In a sample of 16 observations from a normal distribution with a mean of 150 and variance of 256, what is the probability that X will lie less than 160? This is a bit tricky one. Okay. You'll get such numericals in your exam. So how to use this? How to draw this here? Firstly, whenever you see this numerical, you'll have to draw the normal distribution curve. And you'll have to separate these elements. What are these elements known as? Here, whenever I am having observations over here, these are sample observations. So this is small n equals to 16. Whenever the mean is given for the populations, here, this mean is given for the population. So this becomes mu. This is called as mu. Mu equals to 150, population mean. Whenever I write this as variance, so this variance is known as variance. So this variance equals to 256. And what do we do of this variance? This variance, what do? We find a standard deviation from this. Standard deviation. What is the standard deviation? Standard deviation of square root of variance. So what is square root of variance? Square root of variance is square root of 256. So that is equal to 16. Okay. So I get this standard deviation as 16 over here. So once I get this standard deviation as 16, what do? What is required? I want a probability less than 160. What is this 160? This 160 is known as X bar. 160. Now what is the use of all these things? I am plotting it over here. Look at this. Whenever we plot it over here, the central line, this central line is known as a population mean, and that is known as 150 mu. Okay. Then the normal distribution curve is plotted like this. Okay. This is a normal distribution curve. Is equal on all the sides. Always remember. Now, what do I want? My probability should be less than 160. Should be less than 160 means 160 is here. This is always greater than side. So, whatever is greater than 150 will come over here. Whatever is less than 150 will come over here. So, my figure is what? 160. So, it will come over here on this side. Let's say it comes over here. This is my 160 figure. 160. So, that is X bar. Okay. And this is mu. So, this gap is known as a standard error. Standard error. Okay. So, I know this standard error. How to find out this standard error? Standard error is found out using psi dash equals to, see this is the formula. Psi dash equals to, that is standard error. Standard deviation psi upon root of n. This is infinite population. That's why I'm taking psi upon root of n. There are two populations, finite and infinite. For finite population, we have a multiplier that is used. That is not a part of this problem. So let's solve this. Psi is what? 16. Upon root of n is what? Root of, again n is 16. So 16 upon square root of 16, 4. Right? 16 upon 4. So that is equal to 4. So this is my standard error. Now what do I do? Why did I find all these things? Because I have to find the probability. See here, P I want, P, probability. How to find this probability? Say this. For finding this probability, you'll have to use a formula. What is that formula? Let me show you. Okay, let's go to the next slide. I'll try, solve it over here. Okay. Say this. Now, up till now, it's clear, everyone. Everyone is clear on this part. Everyone kindly type yes. Okay. So now what we do, we find out Z. What is this Z? Z factor, this is known as Z. What is the formula for Z? The formula for Z is 1 upon X bar, standard error. 1 upon psi bar, standard error, into X bar minus mu. This is my Z value. What is this 1 upon psi bar? I've got this psi bar. I've got this answer as 4. So 1 upon 4 into what is X bar? 160. So 160 minus 150. Okay. So it is what? Do it everyone. 1 upon 4 into 10. Right? Into 10. So what is the answer? This answer comes to 2.5. 2.5. Everyone clear? This Z is the most important factor while finding the probability. Very important. Okay. So this Z factor will define the probability. How to decide this probability now? Now there comes a separate table called as normal distribution table. Normal distribution table. Okay, normal distribution table. Okay. So what is this normal distribution table? I'll show you. See this. What we do, we go to the normal distribution table. Here, you will be given this in exam. If they ask you this question, they'll definitely give you this, give this in the exam. Okay. So this is known as normal distribution table. I have downloaded it from the internet. You can get it on Google anytime. Okay. So what is this normal distribution table? Here, the values of Z are given. If you look at this, If you check this, the values of Z are given everywhere. I'll just see the values of Z. What are the values of Z? See this. It goes from 0, 0.1, 0.2, 0.3 and it goes on and on and on. And what do we want? Our Z value is what? Z equals to 2.5. So we want that value of 2.5 over here. Where is this 2.5? We'll have to divide this into two parts. One is 2 and second is 0.5. See, this 0.5 is always checked on this side. Okay, and 2 is always checked on this vertical side. So 2 is always horizontal, vertical, and 0.5 is always horizontal. Okay, now check this. So 2 is where is 2? This is my 2 answer. 2. Okay, let me make it red so it becomes easier, isn't it? This is my 2. Where is my 0.5? This is my 0.5. See here, 2.5 I wanted, right? So it will be what? See here, what I have to take, it should be 2.5. So I'll just check this over here, 2 over here, and then directly 2.5 also I'm having it. So this figure, I can't take this as 0.5 over here. Okay, I told you 0.5, but this is 0.05. So I can't take this 0.5 over here. So this will have to remove. We'll take directly 2.5 over here. Because if this would have been 2.05, then the answer would have been 2 over here and then 0.05 over here. We would have matched this figure, this. But now what is the question given? What we'll do? We'll do this. Look at this, okay? So our answer right now is 2.5 only. So what will we do? We'll find 2.5. And what is to be checked later? So 2.5 over here. And then if nothing, no number is there, it means 0, 2.50. So what will I do? I'll check this 2.5 in vertical and 0 in horizontal. So 2.5 over here and 0 is over here. See this 0. So the probability is 0.9938. Getting this, everyone? 0.9938. So this probability which I get, okay, this I'll be using it for my numerical. And that is my real answer. Okay. So our answer becomes over here it is 0.99. One sec, let me write it over here. So our answer over here is 0.9938. So my probability over here is 0.9938. This is my answer. So this numerical, you get it as a case study in exam. They'll ask you various questions on this. So that's why I took this case study. Very important one. Everyone follow this case study till the end. Okay. Some of you are telling me to revise this. Okay. You didn't understand. Some of them didn't understand this. Okay. What I'll do, I'll take various examples over here. What we'll do, we'll take the Z value as 2.5. We have got it. Let me take a Z value of, let's say, 2.55. Suppose if I'm having, see here, our problem is over here now. Our problem is over. So what we'll do, we'll take the Z value as 2.55 for sample. Now we'll find out the value. We'll take two values. Let me see, I'm having 3.55 also. Let's take two values. And how to search in that normal distribution table. So let's search then. Again, let's go back to the table. See this. Go to the table again. Okay, we are here on the table now. First value was what? 2.55. So 2.5 and then see this. Let me remove all these things now, whatever are not needed, because our problem is over. So let me remove this which is not needed. Okay. Now let's take the value. It is 2.55, right? 2.55. This is one and second one is 3.55, right? 3.55. Two values are there. So how to search that? Again, divide this into two parts. This is vertical, this is horizontal. So 2.5 will be searched over here and this horizontal becomes what? This becomes 0.05 because 1.5 is gone, one point is gone over here. Okay. So this becomes 0.05. So first I'll do what? Search 2.5 over here and then I'll search 0.05. This is my 0.05. I'll match these two rows and columns. So my figure comes over here as 0.9946, this figure. So my probability over here becomes 0.9946. Okay, so this is how we find out the probability. Now for the second 3.55, so again divide it into two parts. This is vertical, this is horizontal, 0.05. But what about 3.5? Do I have this 3.5 over here? My maximum is 2.9 over here. Or 2.9 and then 0.09. So 2.99, you can say only maximum 3. What about the next one? Suppose if I am having any number which is greater than 3, greater than 2.99, let's say 2.99. Then I'll take the same probability, 0.9986. So roughly I'll take this probability as 1. So if it is greater than this here, 2.99 means it will go down. Suppose if I want 3.5 and this is 3.5, down means it will go nearest to the 1. So we can take this very simply as 1. Okay. Got it, everyone? This was one of the important parts which I wanted to tell you. Okay. This is 1. Got it, everyone? Are you able to see this? Okay, this part you are not able to see this. Let me show you again. Okay, this part. Watch which one? This one. See this. I'll draw it over here again. 3.55. Hold on. Let me remove this and show you again. 3.55. See this. 3.55. Okay. See this. For 3.55, what do I do? Same. 3.5. So this is greater than 2.99. So I'll search for 3.5 in vertical. Am I getting 3.5? Maximum is what? 2.9. So any number beyond that I can find it. So whenever I can't find this number, what will I do? I'll take this as 1 directly. So my probability becomes 1 if I want to find out for 3.55. Okay. So these are just the some examples which I wanted to show you. Now important part over here is in our problem. The problem was over here, right? So 0.9938. This was the answer in our problem. So has everyone got this? How to use this Z table, normal distribution curve? Will you able to do it separately in exam? Okay. Shall I move ahead now? Say this. This is a new batch coming up on September 4th. Sankalpa batch. All the 4 subjects are covered, numericals, objective questions, case studies, everything is covered. Join it ASAP. Okay, how to join it? Let me show you. See here, we are having a huge discount offer going on. Hi friends, welcome to Adda 24/7. We are in the Sankalpa series for CAIIB and we are covering ABM. Presently we are in Module A. We are in chapter number 2. So let's start. Today we'll be covering some important theory questions as well as some numericals which may come in exam. These are very important numericals as such. Okay, so let's start immediately. Okay, when the items included here, basically it's true or false, huh? But remember, it's not that simple, true or false. Okay, when the items included in the sample are based on the judgment of the individual conducting the sample is said to be non-random sampling. So is it true or false? Look at this. When the elements included in the sample are based on the judgment of the individual. Judgment of the individual means what? Here it means the one who is doing this survey. It's based on his or her judgment. Do you see those singing programs in the television channels? Singing, dancing, all those programs, right? How does it move over there? How does it take place? There are 3 judges, right? All the judges, aapne rula diya, you made me cry, all that natak, everything, okay, drama. So that is basically judgmental sampling because it's based on their judgment whether to select anyone or not. Okay. So when the items included in the sample are based on the judgment of the individual conducting the sample, then the sample is said to be non-random or random. What do you mean by random and non-random? Random means everyone has got equal chance. I'll write it over here. Random means equal chance. Everyone has got equal chance. Okay, chance. And non-random means no equal chance. It's simple. Okay. Non-random means no equal chance. Okay, so here what happens based on the judgment. So it's not an equal chance. So it will be non-random. It's a judgmental. So the answer is true. I'll cut this false over here. So the answer is true over here. Okay. A statistic is a characteristic of population. Is it true or false? Statistic. What is statistic? Always remember what are these statistics. There are two things. Always remember. One is statistic, and second is parameter. Okay, parameter. See here, both are one and the same element, but statistic is for the sample and parameter is for the population. I'll just write POP. Okay. So what is there in statistics here? Both of them contain the same. If I find a mean, let's say I'll give you one example. If I find a mean, and if I find the mean of the sample, it is called a statistic. And if I find the mean of the population, then it's called as parameter. So mean is same, but for whom am I finding? Okay, so that's why statistic is a characteristic of population. So that is false. So true answer is gone. Here false is gone. Okay, next one. A sampling plan that selects members from a population at uniform intervals in time order or space is called a stratified sampling. Now this answer I wanted from you. Uniform intervals. Okay, tell me what are the 4 types of probability sampling? What are the 4 types of probability sampling? Everyone, tell me. Till the time I'll rub this. What are the 4 types of probability sampling? Everyone. Correct. It is. Yes, write in the comment section. It is simple random. Correct. Simple random. I'll write just S random. Simple random. Then second is systematic. Right. Remember this. Systematic. Read this now everyone. Systematic. Third is stratified. And fourth one is cluster. Okay, so I won't be explaining all of them today because this will take a huge lot of time. I'll just focus on this. So when it is selected on uniform intervals in order of space, it is called as what? Either of these 4. So the answer is over here systematic. It is known as systematic. So this stratified is wrong. So the answer is false. Remember, systematic means what? I'll give you 4 examples for this. I'm having, let's say, 50 students. Okay. If I select any 5 by closing my eyes, any 5, so then it is called a simple random. If I tell these 50 students to stand in a straight line and then I select every 10th, I don't know who is on the 10th, so then it's called a systematic. If I tell the students to get collected in terms of marks, 40 to 60%, 60 to 80, 80 to 100, you form various groups on the basis of marks in this pattern, 40 to 60. So then it's called a stratified. If I tell the students to get collected in form of like Tamil Nadu students come this side, Maharashtra students come this side, Kashmir students go that side. When I collect them in the state wise, so that is called as cluster. So here the answer is uniform interval, so it is systematic, and the stratified answer is wrong. Okay. A population comprises groups that have wide variations within the group and less variation from group to group. Which is the appropriate type of sampling method? Now look at this. The same question as I told you earlier. Simple random, systematic, stratified and cluster. Wide variation within the group. So within the group, wide variation. Look at this. Within the group, wide variation. Wide. And outside the group, less variation. So such group is known as cluster. Cluster. Okay. So cluster type of sampling is best for this. Okay. Because what did I tell you about cluster? Goa students on one side. MP students on one side. Okay. Then Delhi students on one side. What am I doing? I'm gathering them as per their areas. So here there can be a clever student also. There can be a dull student also. So huge variation. Similarly over here. Here also, here also. Here also, here also. So huge variation within the group, but Within other groups, Goa also has clever student and MP also has clever student. Delhi also has clever student. Similarly, Goa also has dull student, MP also has dull student, Delhi also has dull student. So within the groups, the variations are less, and this within different groups, the variations are less, and within the single group, the variations are more. That is known as cluster. Okay. Before going ahead, everyone subscribe to Officers Adda 24/7 YouTube channel. In this channel, you will be getting number one free YouTube series. Very important. Free. Okay. Right now, what are you watching? You are watching the same YouTube series. Free YouTube series. So, free YouTube series on all the subjects of JIB and CIB. All. Okay. Secondly, you will be getting the latest updates. Updates from IIBF are directly updated on the site. Videos are uploaded explaining you the updates, not only updates, explanation. Okay. So that's why subscribe to the channel immediately. Click on the bell icon, press the like button and share it. Everyone share it with your friends. Okay. Officers Adda 24/7 YouTube channel. Okay. Suppose you are sampling a population with a mean of 53. What sample size will guarantee that the sample mean is with a population mean of 5.3, not 53. With a population mean of 5.3, what sample size will guarantee that the sample mean is 5.3 and the standard error of the mean is 0? So what is this? Exactly I want. What do you mean by this? What is the question actually? The question is like this. I'm doing a survey of population. Let's say 1 lakh people. I don't know the number. I'm just taking a guess. 1 lakh people. So the mean of the salaries. I'm taking the salaries of all these persons. Okay. Now let's say the mean of 1 lakh persons. The salaries is 5.3. This is my mu. Population mean we call it. What sample size will guarantee that the sample mean is also 5.3? Means this one sample, second sample, third sample, fourth sample. So if I take these 4 samples within this city and the samples are of let's say 100 each, 100 over here, 100 over here, similarly 100 over here and similarly 100 over here. Okay. So all of them are 100 samples. Now what do I want? The sample size will guarantee. Sample mean is also 5.3. The mean of all these, the mean of this plus mean of this, mean of this, mean of this. So total mean, if I do the average of averages of all these, it should also come out to be 5.3. How will it guarantee? It will be guaranteed when you are doing the survey of entire 1 lakh persons. Entire 1 lakh persons. So when this happens, when my population equals to my sample. So I am doing the sampling of all the population. At that time, my sample mean will be exactly the same as that of the population mean. So here the answer is, what sample size will guarantee? Population should be equal to the sample. So the sample size will be equal to the population size. Okay, sample size will be equal to population size. This is your answer. And standard error of the mean is 0. So that automatically becomes 0. What is standard error? Standard error means the difference between this population mean. This is the normal distribution curve. This is known as population mean mu. And this is known as the sample mean x bar. And standard error is this. This standard error. Okay. But tell me, if this x bar and mu are same 5.3, 5.3, then what is the standard error? That is 0. So standard error will be 0 when we have population size equals to sample size. So answer for both is same. Okay. Everyone clear with this concept? Yeah. Move on. Okay. Everyone now. Download Adda 24/7 app on your mobile. In this app, you will be getting the premium study material plus live classes, ebooks, test, everything. Whatever you need for clearing JIB and CAIIB, you'll get it over here. What do you need for clearing JIB and CAIIB? Firstly, you need lectures. So we have online lectures. E-lectures are available. Okay. Live lectures. Then you need books. So e-books are available. Then to check your knowledge, you need tests. So tests are available. What all do you need? That much is enough. How many months are there? Hardly 2-3 months. So that much is enough for you. Okay? Do only this much and you'll clear your exam. Download this app immediately. Now last numerical. In a sample of 64 observations from a normal distribution, a mean of 250 and a variance of 256, what is the probability that x is greater than 260? This is not the same one which I took earlier. This is different. Okay. For this, I'll give you some hints. Whenever you have number of observations, it means this is known as n, small n. Small n equals to 64. Okay. Then what distribution mean? Normal distribution mean of 250. So this is known as mu. This is known as population mean. So that is 250. And variance of 256. Variance you have. Variance equals to 256. So from variance, immediately we will find out the standard deviation. What is the formula for standard deviation? That is called as psi. Remember, psi equals to, what is the relationship between variance and standard deviation? Everyone, what is the relationship? Psi equals to square root of V, variance. So that is equal to square root of 256. Square root of 256. So that is equal to 16. So my standard deviation is 16. Now what do I want? I want probability greater than 260. So what will I do? See this. I'll first find out the standard error, psi dash. This is standard deviation. Standard error equals to standard deviation divided by root of n. So what is standard deviation over here? 16. What is root of n? Root of 64. Okay, so root of 8. So 16 upon 8, right? So equals to 2. So my standard error is 2. Okay. Now what will I do? I'll find out z. Remember these steps, you have to remember it in exam. 1 upon psi dash into x bar minus mu. Okay. So this is my z. So what is my psi dash? 1 upon 2 into what is x bar now? X bar is what is asked. What is asked? 260. See, this x is greater than 260. So this becomes x bar. X bar 260. So 260 minus what is mu? Mu I have told you 250 population mean. So 260 minus 250 is 10. 10 upon 2 is 5. So you get this z value as 5. Now once you get this z value as 5, what you have to do? You have to find the probability. So how to find the probability from z? You have to go to the table. Normal distribution table. Normal distribution table. How to go there? Okay, let me take you. Okay. Hold on. See this. This is a normal distribution table. Are you able to see this? Now, once you see this normal distribution table, remember, what is the value you are getting? You are getting 5, right? What was the value of z? Z value was 5. So, what is the maximum value of z over here? Look at this. This is known as the z value. If you go down. So, maximum value of z is over here is what? 3.4. So, if I am having beyond 3.4, it's of no use. I'll take this last figure only, 0.99998. So this probability becomes 0.998. Okay. So this probability becomes 1. So anything beyond 3.4, I'll take it as 1 only. Okay. So my answer over here will be probability equals to, see here, one sec. This. Okay. So this probability equals to probability. I'll write it over here. Probability equals to, this is greater than 3.4. So it becomes 1. Okay. So the probability that it is greater than this 260. Okay. That is equal to what then? See, I'll draw it over here. You need to understand this. Okay. So this is my mu 250. This is my 260 over here. 260. So I'm getting this probability, this part equals to 1. So this is 1. So I want greater than, but I don't want this. I want greater than. So this part will be what? So probability, this part, the other part will be always, remember, this is my question mark. So my question mark will be 1 minus required probability. I'll call this as P, small p, okay? So P. So required probability equals to 1 minus P. So equals to 1 minus 1 equals to 0. So the chance that you will get greater than 260 is always 0. Less than 260, the probability is 1. Okay, greater than 260, the probability is 0. Okay, very important numerical. It's not that simple. You have to understand this. Okay. So, and that's why I say join the batches. See this batch, Sankalpa batch, starting from September 4th. This was just one of the numericals I took. There are so many tough numericals which I'll be taking in the classes. So join it ASAP. All the 4 subjects are covered. ABM, BFM, ABFM, BRBL, numericals, objective questions, case studies, everything covered. Mahapack. Join the Mahapack. You get live classes, video courses, ebooks, tests, test series, mini and mega marathon, doubt sessions, practice papers, everything you get. What are you waiting for? Isn't it? And presently you are getting the discount also. What is the discount offer? Say the JC code, JC80. If you use the JC80 code, you'll get 80% off and double validity on Mahapack. Let me show you. See this. Go to Adda 24/7. Everyone. Okay. I would suggest you to go through the app always because there is a coin system in apps and you earn 1% extra. Then click on CAIIB November. This one. Okay. Click. Now you'll see this batch. Sankalpa batch. Click on this Sankalpa batch. Okay. Now you see the details. All the product highlights. Read the details. Importantly, I'll tell you. See this. 300 online live classes, 22 test series, 65 ebooks, recorded sessions. So what else do you want? Recorded sessions means if you miss out on any class, you can get back. Okay. Click on buy now. Okay. Click on continue and pay the amount. That's it. Fill in your details, pay the amount. Now I'll show you what is this Mahapack. In Mahapack, you are getting multiple batches, almost 15 batches per subject. JIB, CIB, Mahapack, then CIB, Mahapack 2. Look at this. Okay. Click on it. Again, see the product features, expert faculties, interactive classes, recorded videos. Then, importantly, online classes, 500 plus, 92 test series, 216 ebooks, 949 videos. My God. Go through the product details. Click on buy now. Look at this. It is 80% off. It's 36,837 reduces to 7,367. 80% off. Validity double. What else do you want? Such offers you won't get every now and then. Okay. So join fast. I'll be back tomorrow with another series. Till then, bye. Keep studying and do join the batch. Exam is in what? November? Yeah. Chalo, be fast.